Hello, and thank you for joining me as we review the EPA SSOAP Toolbox. Let's go ahead and get started. First, an agenda, of course. We're going to be talking about EPA SSOAP, but I wanted to break it down into a few different building blocks. So we'll start with the background on myself, on XP Solutions, as well as EPA SSOAP itself. And then we'll actually build the database of EPA SSOAP using real data. As we construct the database, we'll move into characterizing the RDII, or the wet weather event and response from the actual data. A couple notes before we get into the background. This is not a detailed tutorial. This is more of an introduction. That being said, I hope that you leave this talk with a working understanding of how to input data into SSOAP, how to make some logical analysis, how to build up a model, and how to get some output that you have confidence in. That's the main goal. This is not a presentation that's specific to XP Solutions or any other type of software, but there will be a second likely discussion on that very fact. In other words, this first discussion is neutral to any other software. You can download EPA SSOAP free from the EPA website and execute it and run it. And that's the purpose of this talk. But the next talk will be how to integrate that software directly into XP Swim from the input through the workflow to the output. So some direct value to our XP Swim users. This first talk, of course, will be more directed to just the EPA SSOAP users. So a little background before we get into the toolbox itself. XP Solutions has been around for quite some time, over 20 years in fact, of selling and supporting and developing software for the physical environment. In that time, XP Solutions has sold several thousand licenses of different softwares throughout the world. XP Solutions provides several different types of softwares. However, the flagship is XP Swim. That's what many people are familiar with. XP Swim is a dynamic, fully featured piece of software that can model stormwater and river hydraulic systems, but is also equally adept at modeling sanitary sewer systems. My name is Adam Rose. My role is the water and sanitary sewer product manager. And so I have interest in XP Swim from the sanitary side of things. Prior to joining, and I've been at the company for less than a year now, I spent more than a decade in the consultants world, modeling sanitary and water distribution systems, as well as stormwater and atmospheric dispersion systems. So pretty much most of the physical systems out there. My role here, though, is more of what you could call an evangelist for the water and sewer modelers. And so in the course this instance, I'm considering EPA SSOAP and XP Swim from the sanitary side of things. Well, let's talk about SSOAP to some level. Sanitary sewer overflows happen when flow that should be constrained into the system spills out. That can happen for a lot of reasons that are unrelated to wet weather events. In other words, without rainfall, I can have overflows due to maintenance concerns like fats, roots, oils, and grease, structural concerns like a failure in a pipe, perhaps a power failure at a lift station. There are many ways that I can have an overflow in my system. But the SSOAP toolbox, and I should say SSOAP stands for Sanitary Sewer Overflow Analysis and Planning Toolbox. The purpose of that is really to characterize what happens with a wet weather event. So when there is rain in the system, the sanitary sewer system is not leak proof by any stretch. So that rain will enter the system to some extent. It may enter it in a very quick way through a illegal connection or through some structural failures, perhaps in a manhole. So you can have some very direct, quick inflow into the system. And it may enter in a slower, long-term way, infiltration by way of groundwater or cracks in pipes. There's different ways to characterize that, and there are different ways to go about trying to fix that or reduce it. And the toolbox is really built to help the user do that, to take real data, put it into the model, and develop some relatively quick output. And it actually will even allow you to run some scenarios to try to fix some of those results. So with all that being said, to me, the easiest way to understand a piece of software is to get some real data behind it. So let's go ahead and do that. So we'll start with a demonstration. We'll jump over to GIS, and we'll show you what the data looks like. And then once we have an idea of the data that we're going to use, we're going to jump straight into the program and start building. So this is QGIS, which is an open source piece of GIS software. Just to kind of hold the theme of the open source, if you will. Go ahead and let that refresh. This is an actual sewer system in North Texas in the United States, and kind of hard to see from the terrain here, but there's a ridge going east to west across the center of this town. So flow will want to generally run north or south by gravity, gets picked up by two relatively large lift stations and pumped to the treatment plant. So in this case, we're going to concentrate on the north basin, and you'll see line 1, which is a flow meter in that line, and then Duck Creek, which is a rain gauge at the lift station. And anyone who has done any type of calibration of a sanitary sewer system knows that it makes a lot of sense, if you can afford it and if you have the data, to have flow meters and rain gauges, as many as you can have. And of course those are very useful to characterize, of course, dry weather flow. If you have the rain gauge and you have some rainfall events, you can start characterizing the system's response to the rain. And that can vary a lot for a lot of different reasons. Moisture conditions prior to the rainfall event, intensity of the rainfall. There are many things conspiring against the sanitary sewer modeler to make it quite difficult to calibrate, and certainly difficult to project or extrapolate what might happen during a design storm. And again, the idea of the EPA SSOAP Toolbox is really to help make it a little easier for the user. So if you'll bear in mind this line 1 in Duck Creek, other things that are useful would be the amount of linear feet of sanitary sewer system that feeds into that system, as well as the actual area of the sewer shed. That's really principally useful for normalization. So if I have performance indicators based on volume of inflow or infiltration, or the combined wet weather response per surface area or per acre, that's something that a utility can use to help manage and try to set goals. But enough about that. Let's go ahead and just get started with the program. You haven't seen it yet. If you go and find your favorite search engine and just type in EPA SSOAP with the extra S there, you can find it. And so Sanitary Sewer Overflow Analysis and Planning Toolbox, you go type that in. If you find it, download it. It's a standalone executable. If you make it that far, you will be presented with this screen upon opening the software. So to be quite honest with you, not a lot to look at, but it does what it does quite well. And so with that, let's get started and put some data in this thing and see what it does. And so the first thing we need to do is either open an existing database or create a new database. And so for this example, we'll go ahead and create a new database. I'll go up to File. You'll notice up here that File is the only active thing I can do. Everything else is turned off except for Help. So if I go File, I will create a new database. And so I'll call this Example. You can see the .sdb. This is an open database format. So if you have an ODBC connection to any other type of program, you can connect into it. It's quite nice. I hit save, and so now I have example.sdb on my local file system. And now you see I have a lot more options available to me. There's basically two different ways you can run through SSOAP. You can use this kind of plan view and do rainfall, flow, sewer shed, and follow the flow chart. Or you can actually just start up here and you'll see the repeated rainfall, flow, and sewer shed. Your choice. I'm more a visual person, and you'll see some colors changing as we run through this. So I'm going to go in this more of a plan view. And so to repeat one last time, we need rainfall, flow, and sewer shed data. So let's start by adding some rainfall data. If I left click on rainfall, I'll have an option here and management and converter, and you see some grayed out things here. So let's start with management. So we're going to start a new rain gauge. I'll hit add. I'm going to leave the default as new rain gauge, but certainly if you wanted to call it something that made sense on the project, you could do that. You see I have the inches in the rain units and 15 minutes for the time step. I happen to know from the data that we're about to look at that those are accurate, so I'm not going to change those defaults, but certainly you could if you knew that you had 1 hour data or something different. You also see location as a northing and easting. SOAP doesn't do any kind of spatial analysis, so that's not a required input. I leave it blank. Certainly if you had some kind of connection where you could auto-populate that, there would be no harm in putting the data in there correctly. But for the purpose of what we're doing, I'm just going to leave it that way and just hit OK. And now I'll hit close, and so you can see how I changed the color here. I went from white to green, and if I click on rainfall data, I now have all the options. I need to input some data, and I can input data that is text file or delimited, so comma separated, delimited. But to be able to do that, I need to set up a converter. In other words, set up a way that SOAP can take the data in whatever format I have and be able to read it, parse it, and store it in its database. So let's go ahead and set up a converter. I'll hit add, and again, I will leave this the way it is for new converter. I'll tell you what, I'll change that, and just so we know, if we're looking at this table in a different format, we'll know that it's a rain converter, just so we know. Again, the units are inches. And then you see lines to skip, format, and a lot of options. So the best way probably to show that is to show you the actual data. So let me pull up the data, and here you can see this rainfall.csv. I have a header line here that shows you that I have this set as month, day, year, hour, minute, and then rainfall depth itself. You can also see that I go 30 to 45 to 0, 15, so I am in fact in 15-minute intervals. So if I go back over to SOAP, I happen to have month, day, year, hour, minute, rain. So all my columns are in order, which is very nice. Certainly if I needed to change those, I could. So I could switch these to set each column to what it means. I will skip one line because I have the header line, and so I don't want to try to force SOAP to read that because it's text and not integers or decimals, so I want to skip that. You see here the option of military time. I can tell you that my time is in 24-hour periods, which is military time, so I don't need an AM or PM. However, if I had 12-hour time, I could uncheck this and then designate a column to signify if I'm in the morning or the evening. So I'll put that back. The default also is in a comma separated variable format, and so you can see I'm always looking at column, so columns 1 through 6. If instead I had a fixed width, you click here and now I'm over on width. I'll caution you that it is very specific. So if you see the width of 2 for month, it needs to be 2. So in other words, 01 for January, 02 for February. If you have anything other than 2, so if somehow you had 001, it will fail. So it's quite fragile. I would recommend, if you have any control over it, to stick with the separated variable format. It seems to be more robust in my testing. But with that, I'll go ahead and hit OK and hit close. So now I've defined how SOAP should expect to see the data if I import it. So let's go ahead and import it. So rainfall data import. So now you can see I only have one option, my default new rain gauge. So that's where I'm going to be putting this data. I only have one rain gauge that I'm using in my example. The actual project had 2. So I would have 2 rain gauges, one each getting its own data. So now I need to browse to the actual data itself. So you can see here I have this rainfall.csv file, and I hit open, and I will attach the only converter I have, which is the rain converter. I could sub-specify a range. So in other words, if I knew that I only wanted to take a certain set of data, I could do that. In this instance, I'll accept the entire range of data. The only other option presented to me here is what to do if there happen to be duplicate date or times. So you can see there are 3 different options, first or second, or average. I like the default of average. If for some reason there was a duplicated value, we'll take the average, hoping they're probably equal, but if not knowing which one may be better than the others, we'll take the average. You may have a case to try something different, but I like that. Should also note here that if I'm adding more data, it will allow me to append that to existing data. By that I mean if I take, after 1 month, I get a data dump, and I put that data in to SOAP, and then a month later I have another month worth of data, I don't have to regenerate an entire database. I can just add that extra month worth of data into SOAP. It will ask me what to do with it, and I can continue to append data to the end of it. It's kind of a nice feature. I'll go ahead and hit OK, and you can see that almost instantly we're done. Found 178 actual rainfall events during all my data that we had there, and it shows you a little information about it. So you can see here that we had roughly 4 months worth of rainfall data in that time frame. we had 7 inches of rain, and so if you extrapolate that out, you see that's about 21 inches per year. And I can tell you that this area of Texas generally gets 36 inches per year. So it holds true yet again that if you're doing any type of sanitary sewer modeling where you want more than average rain, you'll get less than average rain. It just kind of is what it is. You also see here are the top 5 15-minute rainfall. So basically just showing you max rainfall in depth and then the antecedent conditions during that event. And that's basically it. You're not going to see any statistics here. There will be an area to see statistics quite soon, but it's just giving you some very basic information about it. I can also tell you that if you have any major errors, they will be presented to you here. It gives you at least a beginning level of trying to determine if you have any problems. I'll go ahead and hit close. If you wanted to, I'll warn you here, you see OK and thinking that you might hit OK to close again, yet that will just re-execute. So if I hit OK again, here you see I already have data. What should I do? I can cancel what I'm doing, I can add to what I have, or I can basically wipe clean what I had and redo it. I'm going to hit cancel and hit close again. That happens a few times in SOAP where you may be thinking to hit the spacebar or hit OK, but you really need to hit close. At this point, if I wanted to, I could export that data back out. And so if I had a lot of data over time, I could export it out. There's not really any value to me at this point. That's basically everything that we can do with rainfall. And again, if we had several different meters, we could add all the rainfall data we needed to. So that's roughly one half of the equation. The other half, a quite important one, is flow monitoring data. And it sets up very similar to rainfall, so we'll go through it a little bit faster. Again, you'll see management, converter, import, and export. So management, you'd add a new one. So again, I'll leave it as new meter. I could set the contributing drainage area. So let's just say it's 600 acres. And you see here it is acres. The flow units, so the data you'll see, I happen to know are MGD. Velocity is in feet per second, and depth is in inches. Still with the 15-minute time step, still going to skip over northing and easting. And you can see here again total length of sewer line. So in the example in the GIS, we talked about sewer line length as well as sewer basin area, and this is where you could put that in. So I'll leave that as it is and hit close. Just like before, now I have all the options open to me, but I will go again into converter setup. I need to add a new converter, and I'll just go ahead and say flow converter, just so I know what I'm doing. I know that I'm in MGD, but let's go again look at the data just so we can see it. This is a text file, but it's still delimited the same way. You can see the comments here. Again, I have a header row, so you can see month, day, year, hour, minute, similar to before. Now I have an elevation column, and then you see level, velocity, and flow. So let's go back over to SOAP, see if I can't bring this down just a little bit so we can see it. And if I go to flow monitoring, just so I don't mess anything up, I'll go to converter, hit add, and I'll do it one more time. So we said it's flow converter, and again units MGD, lines to skip 1. Format is still CSV. You see here I have data where I can choose velocity and depth, but they're not required. So if I do have velocity and depth, I can do some scatter plotting or cigar plotting, which can be very useful, but they're not required to determine the volume of inflow. All I really need to have there is the flow rate. In this case, I do have it. Notice how I return velocity and depth off, they get grayed out here, because obviously if I don't have the data, I can't specify where to find it. And you may have one converter that has that data and one that doesn't. You have the flexibility to set that up here. In this case, you see that I do have it, and yet again, we also have military time, so I don't have to set that. So month, day, year, hour, minute, that's the same as it was before. Notice now the 6th column in my data is elevation, and that's not data that I'm going to use in this model. So what I'll do is skip that and set the next one to level. So you can see that level is the same as depth, and so we'll set level to 7, and then velocity to 8, and then flow to 9. Basically what we've done here is skip over column 6 because we're not using it, so you do have some flexibility to skip over columns if there's a column you don't want to read. And again, we don't need the AM PM column, so we'll just hit OK. We close out of that, and now we've set the converter. Since we've set the converter and the management, we can now do importing again. So I'll go ahead and make it full screen, go into import, and I'll leave this as new meter. That's the new meter, the default we set before, and again I have to browse. So I'll browse to that text file. I use my flow converter, the only converter. Same options as before. I can sub-specify a range, but I'll keep the default of entire range. Same options with considering duplicates, and I'll again keep it as average. You have the first and second. You'll see two new options here that I can toggle on or off, and that is what to do with zero or negative flows. So in other words, I have negative flow. Should I just consider that a bad reading and skip it, and then use some type of utility later in SOAP to interpolate that, or could there actually be adverse flow? Same thing with zero flows. Should I consider that to be bad data, or should I use it? In this case, I happen to know from the hydraulics or where this meter is, I should not expect any adverse flows by any stretch, and it's not close enough to the lift station so that there might be zero flow. In other words, the lift station backs up such that it's so surcharged there really is no flow through the meter. That shouldn't happen here, so we'll leave it the way it is and hit OK. It's going to take just a little bit longer to import, but it's still quite quick. So you can see here we brought in 11,000 lines. Didn't have any errors, which is good. You can see that there actually were a dozen or two lines that had zero flow in them, which is something we didn't expect, so we went ahead and threw those out. And that could be something where it was during the very beginning of the installation of the meter, perhaps right before they removed the meter. You can see the range of the data, and it's basically almost the same as the rain gauge, although it's not required. You can see max and min flow and average flow. And that's basically all it's going to show us. Again, we're not going to get in any fancy statistics here. We're just going to see the very basics. And again, if we had any errors, they would throw the big errors to you here, allowing you to pre-process your data again before you get into doing some of the more analysis work in the actual RDII. So we'll hit close, and again hit close. So we're getting really close. We almost have everything we need. This one's pretty simple, sewer shed itself. So let's go ahead, and yet again you see management, converter, and import. So management, I'm going to add one. See here, new sewer shed. Again, we're in acres. I'll go ahead and say, although it's not required, that we had 600 acres, the same area. Now I need to assign one and only one rain gauge and flow meter. So I had a new rain gauge, a new meter, and that I'll talk about loads and tags in the other session, so we'll leave it the way it is right now, and pretty simple. So again, every sewer shed will have one of each gauge and meter. Of course, they're not a one-to-one relationship. I could have one gauge to 10 meters if that's the system I had. So I'll go ahead and hit close. At this point, I go back in. You can see there's a converter set up and an import. And that's quite useful, again, if you're using a database connection. And I guess I should specify, I've said ODBC several times. That's an open database connection. So that's a way that you can interface this, say, with Excel or XP-Swim or Access or a GIS system in a standardized way. That's a very simplified definition of what we mean when we talk about that. So if I had something where perhaps I had 50 different sewer sheds and 50 or 60 different gauges and maybe 80 different flow meters, and I want to simplify that, I could do it through a converter setup and an import. So you can see here, if I were to set this up, I can specify area, gauge, load, and tag as its own table. In this case, I only have 1 meter and 1 gauge, so it's very much overkill to do that. So we'll skip over it. But what I can do is specify the RDII area. Let's go ahead and try that. Again, you'll see management starting to have a theme here. We'll keep that as RDII area. So now what I can do is pick that sewer shed, and recall the sewer shed is 600 acres, and perhaps the area that is interesting to me is a subset of that. So perhaps it's only 400 acres of the parent. And again, I can specify my load and tag, but we'll skip that for now. And I can hit close. So at that point, I've done everything I really need to do. You can see here I can do converter and import again, even through the RDII if I wanted to, but I'll skip over that. So at this point, we've really given the program at a base level everything it needs to calculate RDII and dry weather and wet weather flows. And you may think that we're a long way from doing that. All we've done is process 2 pieces of raw input. And that's true. There's really not too much we need to do. We're going to cover some utilities real quick, and then we'll get into doing some of the actual analysis. So at this point, we've fed everything that directly needs to feed into this database management tool. And again, we see the database management tool here. It's also up as the first box. So you see rainfall, flow, sewer shed. If I left-clicked here, There's the same file, and then you see rainfall, flow, sewer shed. But now that we finally filled in rainfall, flow, and sewer shed, you see utilities. Just as a note, we're going to skip over scenario at this point. We'll cover that in the next session. But we will talk about the utilities. So you see here, first fill in missing flow data. So recall that we could choose to skip any 0 or negative flow data, and we chose to do that. So we hit fill in missing, we can pick the new meter, and we'll go ahead and do an automatic method. And you see here that as long as it's less than 2 hours, we'll interpolate. We hit OK, and there we go. You can see that by far these aren't zeros, these are quite high. Here you see one that's 6. So basically what we've done is filled in that dozen or so empty records from originally, now have data, which is great. And there are many of these I've skipped over, but you can save a lot of these to file. So you can save a lot of these messages to file. It shows you exactly what you have here. I'll hit close and then yet again skip over and hit close again. If I go back to utilities, you can also see here are those scatter graphs I mentioned before. So here's the new meter, the only meter we have. So I specify the entire range and then depth and flow. So of course we have flow, but we also have depth. So if I hit OK, you can see this graph here of flow on the y-axis and depth here on the x-axis. So you can see this is a nice tool if you're just reviewing data to see instances where you may have surcharge, so where the depth goes high but you don't have a change of flow, or maybe where the flow changes significantly without a change in depth, which can mean two different things. We won't get into the details what that means, but you can get that kind of data directly here. You can do the same thing with depth velocity. So I click that, you can see this again where you see a big change in velocity, no change of depth, or the other end of the spectrum, a big change in depth and no change in velocity. So I won't go into the details of what that looks like or how good this data is, but it can tell you from a hydraulic standpoint, if nothing else, do you have a good site? Do you have a site that makes sense that you can use this data to actually be able to determine RDII? And that's important. If I have a site that is subject to a lot of surcharge or subject to things that can skew the results, I don't want to use that site to be doing too much in the review of an RDII system. So some nice, it's simplified but straightforward tools there. Also, another utility you have is rainfall data review. So this is the same data we had before, but more of a graphical. So you can see here where we have depth on the y and again the date here on the x-axis. If I go to utilities again, you can also do more of an analysis. So if I pick that gauge and everything, I can also look and see in a little more detail with more flexibility than my original import, what kind of rainfall events do I have. So here I can specify how long of an event do I choose to be an actual rainfall event. In other words, does it rain for 6 hours or 2 hours to be considered rainfall? And then how do I define dry weather? So let me go ahead and run that, and you can see, without getting into too much of a bog down, you can see an event, a volume, a duration. You can see here antecedent moisture conditions, and you can see I have 16 hours. So it lasts a long time, but not that long of an event. So it's really not too strong an event. You can also see some intensities that are higher. So maybe intensity here where duration was longer, but we had a much bigger flow. Or here's a good one, 2 inches in only 5 hours. So the intensity, the peak intensity, the PI here is higher. So again, a nice way to just analyze the rainfall data specifically for rainfall. Again, these are all utilities that really have nothing to do with RDII or wet weather flow. These are just utilities to help slice and dice some of the data you already have. The other thing I'll show you here, which is really nice, especially if you're into version control and other such things, is this data import log. So you can see here it shows you its own table. Down here I'm at all imports, but you can see I have a rain gauge and a meter, the name of the converter, the type, and then where that file is. So all this data now lives inside this database, but this is some nice metadata about where that data came from. So if I clicked on rainfall, you'd see the only rainfall, but if I had imported this 10 times with new data, they would all show up here. To me, I really appreciate having that kind of legacy of data to be able to see what was happening. One more thing I want to show you, what we're not going to cover, is this configure SSO and junction depth. So this is if you're interfacing with SWIM 5. So that's not something that we need to cover in this more of a basic introduction. So we'll just skip over that. I can see flow data review. It's the final thing. It's not really in an incredibly logical order, but the final thing here is the flow meter. So we hit OK. You can't quite tell from this what it looks like, but if I look at a graph, you can see flow, velocity, and depth. And you can see that here too. You see flow and you see MGD, velocity, and depth. And so the depth in inches is going to throw the scale off a little bit. You can see the depth at the top here, and then you can see the flow at the bottom, and then you can see the velocity. So it can show you all three of the variables that were imported at the same time, which is kind of a nice step. So the final thing I will just touch very briefly on is this little arrow over here, which is really nothing more than a hot link. So there's the technical report in the SSOAP website. But I'll click on that. It actually is not a bad report. I mean, it's old, it's dated, it's 2007, but there is some useful data in there in this beautiful version of how to get that. And you can download a copy directly. If you want to download it, if you don't have it, I'd recommend it. But that's basically this SSO analysis and planning is kind of a dead end. Just like down here, other hydraulic model engines, there's no option there. And that goes back to the fact that SSOAP is not only free, but it's open source. So many people can choose to take the code and develop it how they want. So there's some, what I believe to be purposeful dead ends. They'll let other people continue to develop. But enough about that. So we've brought all the input data in, and we have done some very basic statistics and review about that data. So we're now finally going to get into what most people who are interested in EPA SSOAP want to see, which is how do we define RDII? How do we define dry weather and wet weather flows? How do we come up with the RTK parameters? How can we get some data that we can use in our hydraulic model? Okay, and so to do that, let's head over to RDI Analysis Tool. If I left click, I'll see Analysis Management. And if I click that, here we are again at another management interface. I'll hit Add, and yet again keep the name as the default, New Analysis. I don't have any options here for flow meter and rain gauge, but if I had many of each, then I could have many different analysis. And for each one of those analysis, I can set base flow rate, if I want to pull out base flow, and daily dry weather flow adjustments, should I have any. One last thing I'll mention before I just hit OK here is that if you want to set a default RTK or initial abstraction terms for short, medium, and long for any of your wet weather events in any specific analysis, you could set those here. And what that means is for each event that you begin to characterize, and we'll do that in just a second, when you bring up the values, they won't all be zeros. They'll be whatever you set. I don't know that I'd call that advanced, but it's something that you can use if you have some pretty uniform characterized events. But I'll hit OK for now and hit close. Now if I go to RDI Tools, I have more options available, and we'll start with dry weather flow analysis. I'll caution you that you may want to jump ahead into maybe a wet weather flow or some statistical analysis. It really makes sense to go in order. Most of these steps are quite quick. And the program won't tell you exactly what it's doing, but if you jumped right into wet weather flow analysis and tried to screen out actual events before you did the dry weather flow analysis, you'll get different values. So I just caution you to make sure you're being pretty methodical here. And again, it's pretty quick. So let's start with this one, automatic dry weather flow day determination. And it may look like there's a whole lot of options in this one. It's really not too bad. And so to start with, we only have one option, and it's our flow meter. And then we have the option of treating weekdays and weekends differently. We'll treat them the same. You can pull out missing data points, which we would like to do. And then if you look down here, if you wanted to remove those based on rainfall, what rain gauge would you use? And then how would you set the rainfall based on that? Luckily, we've already gone through and screened out all of our rainfall data. We don't have any zeros, so basically we can pretty much negate everything here and just hit OK. So now we're determining all the dry weather flow statistics. And again, consider when we're looking at a wet weather event on, say, a Tuesday, we want to compare that to the dry weather flow on any given Tuesday that's dry, as well as the dry weather flow overall. Well, either of those last two can't be compared to other wet weather events. In other words, if I want to compare wet weather to dry weather, my dry weather can't include wet weather. That may sound a little confusing, but basically what we're trying to do here is pull out all the events where there was rainfall. So when I say dry weather, I really want it to be dry, strictly from human use and not from rain that has got into the system. Hopefully that's not overly confusing. Maybe it is, and I apologize, but that's the way I think about it. And so look at this here. You can see we've written some information. You can see some averages. Look down here on weekdays, and you can see 6 days here. Okay, out of the 118 days, you can see 6 days originally that we have pulled out. And so just bear in mind there are 6 days. And I'll close that because the next step is what we might want to do with those 6 days. So I go to dry weather analysis. I can do a manual removal or an automatic removal. In other words, can I adjust my dry weather flow by removing all days that don't appear to be dry weather flow, or can I automatically just take those days and pull them down in flow such that they act kind of like a dry weather flow even though they're not. So if I chose to do the manual, I hit OK, and you can see this is one of those 6 days, 6/28/2012. And if I were to page forward, you can see the navigation here. So if I did this Control N to go to the next, you see 6/29. We jump to 7/26. So I go through all 6 days and determine whether or not I want to keep or discard or update the average dry weather flow based on that. So in this case, I won't make any adjustments by manual means. I'll be lazy and just say OK. If you notice, that was also an option underneath weekday is weekend. Same idea. If I want to do any changes, I could do that there. You do have the option to set holidays. When you click on that, you'll see how old this program is. It starts at 2007 and goes all the way through 2011. Certainly, you could do some changing to add the holidays if you wanted to do some holiday determination. There's a lot of interesting sociology on how major events or holidays or even weekdays and weekends affect flow. So again, if you have very detailed analysis, and that type of thing would make a difference. So if you happen to be seeing a wet weather flow on a Thursday and you're comparing it to Thanksgiving, then that's where you could make those adjustments. Now you have the option to view the dry weather hydrograph or statistics. This is pretty similar to what you saw in the database management tool. Slight changes here based on actual characterization and getting into more dry weather versus average daily flow versus wet weather. And again, you have the same options similar before where you can do some statistics. This is not a whole lot to see here. You can see average max, average, and average min for weekday and weekend. So not a lot of options there, but it can be useful. It can be really useful if you're using that to design a treatment plan or something. And so now we're going to jump down here and you can see identify minimum nighttime flows. This can be very useful. I'll leave the defaults here and hit OK. And it's going to give me the, if you will, top 10 or bottom 10, depending on the way you look at it, nighttime flows. This can be quite useful if you're trying to characterize groundwater inflow or trying to characterize inflow into the system that has very little to do with human interaction. So we all know there will be some level of flow even at 2 o'clock in the morning, but there may be an instance where it's groundwater intrusion, and there may just be other reasons why you want to know what the minimum flow is. Perhaps you're doing some work on the hydraulics of the system to determine whether or not you might have deposition of sediment. A couple more things to look at in dry weather flow. I had half a dozen or so days that were pulled out when I did automatic dry weather flow day determination. I did not make any manual changes to those. Well, I can make an automatic change here. Click automatic, and that's the only analysis I have, and hit OK. Those are our events. So same events as before, and we're making adjustments. In almost every case, we're pulling down the flow from that 628 or 629 to be more of an actual dry weather flow. And because I did that, the final thing I can see in dry weather flow analysis is I have that table. So I can go back and make any number of changes to dry weather flow and then rerun that and check the adjustments. Okay, so we're getting closer. We've gone through and did, in this case, very quick screening of dry weather flow. So now we need to get into wet weather flow. So the first thing, and one of the most important things I think the program is doing, is to determine the event identification. In other words, I might have some rain one day or another day. How do I determine a threshold for an event? And also, how do I determine the duration for an event? And so you can see here, I have my new analysis. I'm going to leave the defaults here for averaging time steps, the minimum peak INI, and you can read the rest. But I'll go ahead and just hit OK and let it run through. And so you can see here that based on all the data I have and the fact that I've screened out dry weather flow and I've compared everything else, that the program says that I have 4 events based on the defaults you just saw that are actually worth looking at, basically. In other words, there were 4 events, rain fell out of the sky 4 times, that had enough of an impact on the system that I could characterize it as a rainfall-derived inflow or infiltration event. I'll go ahead and hit close. So that's good. So now let's actually try to do that. If you notice, I hit this event table, and there are my 4 events, and all my RTK and initial abstraction parameters are all 0, which is kind of a bummer. It would be nice if they were automatically pre-populated, but they're not. So at this point, the next biggest goal is to basically populate this table. We want this table populated as closely as we can. So how can we do that? Well, you can see I'm going to skip over import and export, right? Because if we had a beautiful table, we would do that. I don't have statistics really at all, so there's no point in any of this. We have to run all the way back down at the bottom to RDII graph. And it's really kind of a shame it's hidden down here, but that's really where, in my opinion, you want to do your work. So however long we've been talking so far, this is where you want to be. Now I'll hit graph. I only have one analysis, and I'm going to make it full screen for you. A lot to see here. If I go to graph, I can start turning off some of these. So what I'm going to do is turn off some of my dry weather flow, and what I really want to just see is honestly observed RDII and simulated RDII. I'm going to turn off everything else. I'll leave rainfall for now. Groundwater I'll turn off. Nighttime I'll turn off. I'll leave the individual curves, and that's basically it. It says events here, but you don't see any events. That's because under view, you need to hit to see the actual events. If I try to click up and down, here are my 4 events, right? So here I am, and now I have my actual event-specific parameters. Recall, if I had defaults, I could load them here, but I don't. One other thing I'd recommend doing is hitting this auto apply changes. That basically means if I make changes, you can see here I'm changing the time, it automatically changes over here. But really what we're going to do now is show you how you can set RTK, and you can even put in a description, hit apply, and actually begin to build the parameters so that you can fit the curve. So there's my RTK right now, which is basically at 0, right? So there's nothing there, and I'm trying to, based on this event, and you can see the bounds here, set, here's a short, a medium, and somewhat of a long-term response. So the goal here is to set these parameters to help make this gold line look like the red line. If I can do that for all 4 events, I've basically accomplished a huge part of what I'm trying to do. So let's just pick one event, and we'll go ahead and try to establish some RTK parameters. And I'll just step through and see here's event 1, again rainfall up here and the response. Here's a second event, kind of a spike here. Again, this is all to 0, so you're going to see at this point only the predicted response due to the actual rainfall. So this is our last event. So let's just pick this event. You can see kind of a nice distribution of rainfall. Again, this is what we think when we pull out everything we see. Well, in fact, let me just go ahead and show you that. Let me add that back in. So you can see here, the green is what we actually see. And through the magic of SSOAP, we've pulled out the actual diurnal pattern. So even though it didn't occur because it was raining, we pulled that out. The difference of the two is right here is the red, which you can see here is observed RDII, which is going to be, and we haven't really done any kind of cleaning on that, so in some cases it's negative, which isn't true, but you can see here this volume here is where we think is actually extra volume specifically due to rainfall. So let me go ahead and go back to my event and jump over to event 4. So again, same data as before, we always had that red line, but now you can kind of see where it came from. This red line is basically the difference here, the difference in volume between those 2 curves. So basically, you know, there are some algorithms, there are some nice papers. Again, RTK's been around for decades, but if nothing else, you can just begin to enter in some data and try to fit the curves together. So this R is a fraction, so it's going to be a small number. And so let me just try a number here. T is a time, so usually it's going to be something small. for the short term, and then K is usually bigger than T. In other words, the lag time is typically longer than the time to peak. Let's see what happens. So when I run that there, just those values there, you can see how now I'm getting close. Actually getting kind of close, only with short term. It's a pretty short term response. I could add something medium if I wanted to. It would probably be a smaller number. This medium would be smaller than the short. Let's see. And again, I'm just going to plug some numbers in here just to see what we look like. It's hard to say for sure. That's probably going to be, yeah, that's close. It's close here. So again, you can see the difference. Something to point out here. So if I make this number big, it'll jump up high, right? And it's kind of offset by the T. So if I made the T high, it would jump back down, but spread out. So it's a little bit of experience, a little bit of trial and error, a little bit of both. Let's just assume that we like this. So you can see the total R 0.04. You see all of our parameters. So we've pretty well established something where we're a little long. We don't quite hit the peak, or we're a little long, but I'm not going to go through and adjust it perfectly. I can hit apply, but since I'm doing auto apply, I don't have to worry about that. I'll hit OK. I'm going to close this out. So now notice if I hit close and go to RDI analysis, wet weather flow event table, magically there's our event. So event 4 has been filled out. You could follow those for event 1, 2, and 3. And if you had antecedent moisture, you could do that too for each of your analysis. I only have one. So now that I have that, what can I do with that? Well, I could export or import if I needed to. And then I can start doing something a little bit more useful. There's some event statistics. So now, recall way back when we started setting some sewer length and area. So now I can actually come up with some metrics. So the total volume, that's just based on the area under the curve. But now, finally, some metrics. So I&I volume per linear foot of sewer, how much I&I we have over the sewer shed area. So that's kind of a depth inches, even though it's volume divided by area, and some other really nice metrics that you can start to track over time. I can also start doing here, again, I don't really have a lot of options, but if I go to 4, so this is the one where I chose an event, you can actually start seeing some comparisons. So you can see here, how close was I with what I said, so what I simulated versus what was observed, and the differences. So you can see slightly underestimating the total flow, but overestimating the total volume. And that makes sense, right? The total peak, I was under that, but my trailing leg was further out. So, but that's in more of a quantitative way. And of course, it's going to be nothing here on these because I haven't done anything yet. So if I did all my statistics, I could see all those. That's really useful. Rainfall intensity statistics, if I chose a file name and browse to that, it will basically export out statistics. To me, not that useful. I will say that if you're going to use it, open up the text file in Excel, because it's going to be about 50 columns wide, and it doesn't really make a lot of sense, even in a better text editor, to be able to view that. So I wouldn't really worry about that. Okay, so I promised last few things we're going to talk about for this program. I'm going to close that out and show you some even broader statistical analysis. This is really nice. The first of the statistical analysis here, this median R, hit OK. What you'll see here is I had 4 events. Now, again, I don't have all the data set, so don't read too much into it, but you can start getting a distribution of your fast, medium, and slow for RT and K, which is really nice. You can also, if you have enough events, begin to characterize those per month. And so that can be really nice. Certain hydraulic softwares can handle RTK parameters that are varied by month. And again, consider that you have antecedent moisture, you have a lot of things affecting even the best representation of what's happening. So if you actually, in this case, for 3 months, we got only 21 inches of rain and we wanted 36 inches, but we got 4 events, but they didn't all act the same. How can we start to begin to set up what exactly the RTK look like once we get everything really nice? And why would we want to do that? Well, we got 4 events, but none of those were any kind of design storm event. So if we're trying to extrapolate what we might want to use in a future event, it's really nice to be able to run some statistics on those. I'd like to be able to show you some of these other statistics, but only running through one, it's not really going to work. I'll try this one, which is just multiple variable. And you can see, again, a lot of, in this case, nonsense, unfortunately, because I haven't run it yet, but you can start running through and getting some regressions. And again, the point here is I'm trying to develop enough information, enough body of knowledge to be able to start projecting what I might be able to do with a design storm or a future event. Okay, so now I'm going to call RDII analysis done. And so you may think there are a lot of boxes left. I'm just going to skip ahead to say that SWIM 5 interfacing are all how to interface with the hydraulic model, and that's beyond what I'm trying to cover here. And honestly, when I do cover that, I'll be covering with XP Swim, not SWIM 5, so covering it with a different hydraulic model. Other hydraulic model engines is nothing. That doesn't even have a click. Condition assessment is actually a pretty useful tool. I'm not going to run it, but I'll show you what you can do. You can see here you can set prioritization areas. So let's do that through a manager. If I had a new analysis, which I set, then I can actually determine what exactly do I want to set for prioritization. In other words, is it peak volume per length? Is it any of those metrics we saw? Or is it really the fast response? Is it those illegal connections, downspouts? Is it slow response? Is it some kind of groundwater infiltration, medium response? And there's lots of different ways I can set through setting up this type of condition assessment support tool. And again, I'm not going to get into the details here. That might even be a third talk, but I just want you to be able to see what you can do. You can also do that here through pre and post rehabilitation. And so I consider that as I have some data and I run it, and then I either slip line a line or make some type of change to the line and collect more actual data or make some assumptions on what I might get. But generally it's the former, which is I have data, I go ahead and do some kind of rehabilitation, I get new data, and I can compare those. And hopefully at that point, I know we're at the end of this, but you can start seeing the value in setting up some of these scenarios. So the only thing I've really left is this hydrograph generation tool, and I'll just step through that briefly. So the final thing I'll talk about is a hydrograph generation tool, and basically, as you can see through the flowchart, it principally feeds the SWIM 5 interfacing tool, and I already said I wasn't going to cover that, so you may wonder why I'm going to cover something that feeds a tool I'm not going to talk about. But I just want to briefly say, in my opinion, unless you're going to interface it with SWIM 5, avoid this area. It'll present a lot of the very same interfaces that you saw before when we actually set the RTK parameters. If you notice here, I can set RTK, initial abstraction. If I make changes, it'll make a change here in this hydrograph. So it looks very similar. The problem is it's not as well connected into SOAP. It's basically disconnected and set such that you can export it out in a SWIM, and that's not really something you want to do. So I would just say that avoid this because there's no direct value unless you're going to interface with SWIM 5 or some hydraulic engine. And again, we're going to cover that in more detail later. So the summary is that all your main work is going to be in RDII, wet weather flow, graph. Well, we finally reached the end. I thought it was going to be half an hour, but it was more like an hour. I hope that you enjoyed what you heard. There's a lot to cover in the world of sanitary sewer modeling. There's also a lot to cover in SOAP. And again, this wasn't meant to be technically perfect or cover every single aspect. It is really meant to give the users who want to simulate a wet weather flow event a leg up in how to do that. You can see here my contact information. If you have any questions or concerns, please don't hesitate to give me a call or an email. And soon you will see another talk about how to interface EPA SSOAP into XP Swim. Thanks again.